Welcome back, everybody. In this video, we'll be starting up section 4.4, which is on counting. On the face of it, having a section called counting sounds like really simple, like we're just counting on our fingers or something, but it's not as simple as all that. As you saw with the example we had done with the cards, drawing 4 cards, what is the probability of finding at least one face card? We saw that counting some of these situations can get a little tricky, and so this is more kind of what this section is about. Some of these kind of more interesting counting methods. So the first thing we'll look at is called the multiplication counting rule, and depending on which book you're looking in or what part of Google or YouTube you're on, it can go by other names. You might see it called the fundamental counting principle or fundamental principle of counting. So any of those names refers to this multiplication counting rule. And it goes like this. If you have a sequence of events in which the first event can occur in n1 ways, the second event can occur in n2 ways, and the third event can occur in n3 ways, and so on, the number of total outcomes, that is the number of ways of getting the whole thing done, is n1 times n2 times n3, and so on, up to however many factors were included. So examples. Okay, so let's say that you have 2 pairs of pants and 4 shirts, and we want to know in how many ways there are for you to choose what to wear. So according to the multiplication counting rule, if there's 2 ways to choose your pants and 4 ways to choose your shirt, then there's a total of 2 times 4, 8 ways to get the whole task completed. Of course, in here, the assumption is that you're only wearing 1 pair of pants and 1 pair and 1 shirt, right? So to kind of see how this is working with this example, at least, we saw that there's 2 pairs of pants. Let's say you have a pair of jeans and then black slacks or something, okay? And so once you've chosen that, and there's 2 choices, there's 4 choices for how to select the shirt. And let's say that there's white, blue, red, and yellow. Just to keep it different letters, I was going to use B again for black, but let's not. Okay, so with white, blue, red, yellow. With each choice of pants, there's 4 choices for shirts. So you could wear jeans with a white shirt, or you could wear the black pants with the yellow shirt. So there's a total of 2 times 4 or 8 possibilities. And of course, here we're not doing any kind of anything where you wouldn't wear jeans with a yellow shirt or something like that. So there's no limitations. That is, the choice of pants doesn't influence anything about the choice of shirt that comes later. All there is there's 2 choices for how the pants can be selected, 4 choices for how the shirt could be selected. 2 times 4 is 8, and that's the end of it. Okay, more examples. Okay, how many 3-digit numbers are divisible by 5? So this will be interesting. First of all, when we're thinking of a 3-digit number, we're thinking of a number like 507, okay, which actually has 3 digits. We're not going to count like 0 to 1, okay? We're not going to call that a 3-digit number. It would be 21, which is a 2-digit number. So we need to think about how we would construct our 3-digit number. So, if I ask you to think of a 3-digit number, all of you probably will think of something different. So we do need to break this down into some subtasks, though. We need to figure out what the first digit could be. The first digit could be anything from 1 through 9. As I said a second ago, we're not going to count like the number 0 to 1 as a 3-digit number. It's only a 2-digit number. It's 21. So the first digit can only be anything from 1 through 9. The middle digit, though, could be a 0. So there are 10 choices for it, 0 through 9. So there's 9 choices for the first digit and 10 choices for the middle digit. What could the last digit be? We need to make up numbers divisible by 5. We know that for a number to be divisible by 5, like 350 is, or 210 is, or 155 is, it needs to end in either a 0 or a 5, right? So there's 2 choices what the last digit can be. It has to be either a 0 or a 5. Okay, so we've broken down our big task into 3 subtasks. There's 9 ways to choose the first digit, 10 ways to choose the second digit, and 2 ways to choose that last digit. So 9 times 10 is 90, times 2, 180. So there's 180 3-digit numbers that are divisible by 5. Okay, so we've actually seen our use of the fundamental counting principle before. And so let me add in one extra example here. I'd said that if you have 3 kids, how many possibilities are there? 2 boys and a girl, all 3 boys, and so on. And I'd said several times, okay, there's 8. The size of the sample space is 8. So you have to think about, is the first kid a boy or a girl? And there's 2 possibilities. Is the second kid a boy or a girl? Is there 2 possibilities? And then is the third kid a boy or a girl? And there's 2 possibilities. So 2 times 2 times 2, and that's 8. Okay, the same kind of situation comes up when you're tossing a coin and the coin comes out either heads or tails. The first toss is either heads or tails, 2 choices. Second toss is either heads or tails, again, 2 choices. And then the last one will be also 2 choices. So 2 times 2 times 2, or 8 possibilities. Okay, next example. Suppose that you have 4 phone calls to make. And we want to know how many ways there are for you to arrange the calls. Let's say you have to call your boss, you have to call your significant other, and then your sister, and then Target or something. Okay, you got 4 phone calls to make. You're going to call your sister first and then Target, or you're going to call your boss back first. How many ways are there for you to reorder these calls? So let's say that you have your boss, your sister, I forgot what I said before, sorry, your boss, your sister, and then your significant other, and then Target. Okay, so you need to think about how you're going to do this. Say, okay, well, who am I going to call back first? Okay, there's 4 possibilities for who that first call will be. Okay, if you're smart, you'll call your significant other first. Okay, so let's say you do that first call, get that done. Okay, then you have to do the remaining calls next. Let's call your boss back second. Okay, there's 3 choices for who to call second. Okay, let's make it the boss called second. There's only 3 possibilities. So you've called your boss and your significant other. So now, is it your sister or a Target? There's 2 possibilities to choose from for that third call. And let's say it's Target. You want to find out your order came in or whatever. Okay, and then finally you only have 1 call to make, and so there's only 1 way to choose from 1 item. So there's only 1 possibility. And so this works out to be 4 times 3 times 2 times 1, or 24. There's 24 ways of reordering those 4 calls. It turns out that that calculation of multiplying together possibilities, but where it decreases by 1 at each stage, 4, 3, 2, 1, that occurs often enough. It gets its own name and notation. And it's called the factorial, and its symbol is kind of funny. It's an exclamation point, which is, like I said, kind of funny. And so it goes like this. For any whole number n factorial, that's how you read the exclamation point, is n factorial, is n times n minus 1 times n minus 2, the dots you could read out loud as n, so on, all the way down to 3 times 2 times 1. Okay, I'll go on to the next part in a minute. I just wanted to give you some examples. So 3 factorial is 3 times 2 times 1, or 6. We saw that 24, that was really 4 factorial, 4 times 3 times 2 times 1, or 24. And you can also see that 4 factorial is 4 times 3 factorial, right? Because 3 factorial is 6, and 4 times 6 is 24. And then let me skip over 5 for a second, just for fun. We'll do 6. That's 6 times 5 times 4 times 3 times 2 times 1. And so this is going to be 6 times 5, that's 30, times 24. And what is that, 720? Okay, so there's a couple of factorials. You could also define this as a piecewise function if you learned about those in algebra. So n factorial is 1 if n is less than 2. And it's n times n minus 1 factorial if n is at least 2. So this is kind of interesting because The factorial is defined in terms of itself in this way. If n is at least 2, it's n times the preceding factorial. Okay, 0 factorial is defined to be 1, and 1 factorial is defined to be 1. So 0 factorial is 1, 1 factorial is 1, 2 factorial is going to be 2. Okay, so there's a few. What's extra important is what it tells you. N factorial tells you the number of ways of arranging n objects, like those 4 phone calls. So that's what n factorial tells you. How many ways are there for you to arrange n objects? Okay, so a little example. How many ways are there for you to arrange 5 books on a shelf? Do you want to put them in alphabetical order, by title, by author, by the size of the binding from biggest to smallest or smallest to biggest, by publication date, by how much you like the book, the reverse of any of those criteria? How many ways are there for you to line up those 5 books? Well, it would be 5 factorial ways. That's 5 times 4 times 3 times 2 times 1, or 120. There's 120 ways for you to arrange those 5 books on the bookshelf. Okay, and that's what n factorial tells you, the number of ways of arranging n things. All right, so here are some more examples of the fundamental counting principle. Let's say you go and open a bank account and you have to pick a new ATM code, and you're supposed to make it 4 digits long, and there can be no repeats for whatever reason, okay? Other than that, there's no other restrictions, so 4 digits long. So the first digit could be anything, so there are 10 choices, but there's not supposed to be any repeats, so whatever digit you chose first, that's out of the question now. So there's only 9 choices for the second digit. And then for the third digit, we've already excluded 2. So there's 8 left. And then finally, there's only 7 digits remaining for the fourth digit for us to choose from. Okay, so then that's 956, 560 times 9. Or 3,024. So there's 3,024 ATM codes if we don't repeat anything. Okay, one thing that you'll notice here is that this is not 10 factorial. So that's important to note. I just got done talking about factorials a minute ago, but it's not 10 factorial. And why? Because the factorial counts down to 1, right? 10 factorial would have been 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, and 1, right? 10 factorial counts all the way down to 1, but here we only counted down to 7. Okay, so it's not 10 factorial. Okay, so another example, the same as above with the ATM code, only the first digit can't be a 0 for whatever reason. So what are our possibilities? Okay, for the first digit, there are 9 choices, right? It could be anything from 1 to 9. Okay, let's say we pick out a 5 for our first digit. Now, when you go to do the second digit, you need to think about how many possibilities there are. We're told that the first digit cannot be a 0, and sure enough, it wasn't. We picked out a 5. But if there can be no repeats, can the second digit be a 5? Okay, second digit cannot be a 5 because it says no repeats. So we are able to use the 0, but we're not able to use the 5. So we still have only 9 choices. Okay, so be sure that you see where that 9 comes from. We've included the 0 that we weren't using in the first place, but now we're not going to use whatever number was chosen first. Let's say we choose a 4 for the second digit. And then from here on out, it's just no repeats, but we can still use the 0. So there's 8 choices, let's say 7. And then for the last digit, there's 7 possibilities. Let's say we choose a 2. It'd be funny if I got your ATM code here. Hopefully I did not. Okay, so then that's 56 times 81, right? All right, so 4,536 possibilities. Okay. Okay, another example. Let's say you have a sales route of 6 stores. You get a job working for Pepsi. You drive around to liquor stores and ATM and AMPMs and stuff, and try to get them to buy 12 packs of Pepsi or whatever. And so you've got this route of 6 stores. And so you want to figure out how many ways there are for you to plan your route. You don't want to drive from Desert Hot Springs to Indio and then back to Palm Springs, then back to Coachella or anything like that, right? So you'd probably like to optimize your route in terms of how much driving it's going to take you, and maybe consider traffic as well. So how many ways are there for you to reorder those 6 stores? So you have 6 choices for which store to go to first. And then once you've gone to that store, there's only 5 stores left. And you can tell where this is going. 4 stores, then 3 stores, 2, then 1. So this is 6 factorial ways there are for you to arrange those 6 stores. So then 6 factorial was 720. So there are 720 ways for you to arrange all 6 of those stores. Okay, we'd mentioned this before, but worth repeating. We're going to flip 3 coins. We want to know how many outcomes there are. So for this one, we're not counting arrangements of something. Here we're counting just possibilities. There are 2 choices for how the first coin comes out, 2 choices for the second, and 2 choices for the third. So that's 2 times 2 times 2, or just 8 possibilities for how those 3 coins could come out. Okay, you want to make sure that you understand the difference between these 2 questions. I know one is about stores and the other one's about coins, but separate from that, you need to understand what's different about the 2 problems. In the first case, we have a fixed set of objects and we're counting how many ways there are for us to arrange them, put them in a different order. In the second case with the coins, we're not trying to put them in any order. We're trying to figure out number of possibilities. We're breaking down a big task into subtasks and multiplying together the ways of completing those subtasks. So make sure that you can distinguish between those 2 types of problems. All right, so we have a few more examples. In this one, you're going to make a sandwich. There's 3 kinds of bread to choose from. And there's 3 types of meat available, and you're going to choose 2. Out of the 4 cheeses, you'll pick 1. You can optionally include lettuce, tomato, onion, and mayo, if you like. Okay, we want to know how many possible sandwiches there are for you to make. I think implicit in here is that you're only going to use 1 type of bread, even though it doesn't say that there. So we're going to pick a bread and then choose 2 out of the 3 meats. And then out of the 4 cheeses, we will pick 1, and then optionally on the other stuff. So that's a big task. We're going to break it down into subtasks. So how many ways are there to get this done? So we need to make a choice about the bread, the meat, the cheese, and then everything else. So we're breaking down a big task into subtasks and counting the number of ways of completing each subtask. So it's going to be a fundamental counting principle problem. So there's 3 kinds of bread. Okay, so let's start there. So there's 3 kinds of bread. And then it says out of the 3 available meats, we're going to choose 2. So how to do that? Well, if there's 3 kinds of meat, let's say that there's turkey, roast beef, and mortadella or something, right? There's 3 kinds of meat. How many ways are there for you to choose 2? Well, that would correspond to the number of ways of choosing the one you don't put on, right? Okay, so let's skip the turkey or whatever. Okay, so there's 3 possibilities there. So there are 3 possibilities for the type of meat. Okay, here we're not counting differently as like, okay, is the mortadella on top or the roast beef on top? It's just on the sandwich or it isn't. So the order that the meat is put on doesn't make any difference, okay? All right, so next, out of the 4 cheeses, we're going to choose 1. Okay, so here, just if we stop here, we've got 3 times 3 times 4, or 36 possible sandwiches. But now we have to decide on everything else. So we have lettuce, tomato, onion, and mayo. And each of these is a yes or no question. Picture you've gone into the sandwich shop and you're ordering the sandwich and they say, okay, do you want lettuce? Yes or no. Do you want tomato? Yes or no. So there's 2 possibilities as to whether or not your sandwich can have lettuce. So there's 2 possibilities. Will it have tomato or won't it? So there's 2 possibilities. Onion, 2 possibilities, yes or no. And then finally mayo, 2 possibilities. Okay, so we're going to multiply all of those together. and see what we get. So we should have 36 times 16, or 576 possible sandwiches. All right, so this was a fundamental counting principle question. Okay, a couple more examples. Okay, so first of all, this is back to arranging books. How many ways are there for you to line up 4 softcover books and 3 hardcover books on a shelf? And what's going to complicate things is we want to keep the like bindings together. So keep all the soft covers together and keep all the hard covers together. So at this point, pause the video and try this yourself, and then restart the video and see how you did. Okay, so let's think. We have kind of a big task, how to arrange these books. We're going to break it down into subtasks. Okay, how many ways are there for us to arrange the hardcover books? Well, we learned about how the factorial tells us the number of ways of arranging n objects, and there's 3 hardcover books, so there's 3 factorial ways to arrange those. The softcover books, there are 4, so there will be 4 factorial ways to arrange those. Okay, and so then we have to decide, okay, once we've arranged all the hardcover books and all the softcover books, we have to decide when they're sitting there on the shelf, will it be the soft covers on the left, then hard covers, or will the hard covers be on the left, then the soft covers? So we'll have to decide which is on the left. Okay, and there's 2 possibilities. Are you going to put the hard cover or soft cover on the left? So it'll be 3 factorial, that's 6, times 4 factorial, which was 24, and that's multiplied by 2. So that's 288. Okay, so there's 288 ways of arranging those books. Okay, so going to the movies next. For this first part, it says, Mom and Dad and son and daughter are going to the movies. Okay, for part A, we want to know how many ways are there for us to seat everyone. Okay, so if we're going to seat everyone, just pick out the 4 seats. We're going to assume here that they all sit together, okay? Is it going to be mom and dad, then son and daughter? Is it going to be mom on one end and dad on the other? There's lots of ways, right? So we're arranging 4 people. So there are 4 factorial, or 24 ways. Okay. All right, so moving on. We want to see, well, what if we require that the kids don't sit on the aisle? We don't want them getting up and running off in the middle of the movie, or sticking their foot out and tripping somebody or anything like that. So, or whatever. So we don't want the kids to sit on the aisle. And let's just assume there's only one aisle side here. Okay, so if the kids can't sit on the aisle, let's figure this out. For one thing, let's check and make sure that we got to make this make sense. We found out that there's 24 possibilities altogether if there's no restrictions, right? If we just let everybody sit wherever, 24 possibilities. If we start restricting things now and say, okay, well, let's not let the kids sit on the aisle, will that increase or decrease the number of possibilities? That will decrease the number of possibilities. If you start restricting what can happen, that's going to lower the number of possibilities. Okay, so let's think about what's possible. Okay, so let's say that the aisle is right here, and here's the 4 seats. So we need to think about how can we assign these seats in such a way that the kids don't sit on the aisle. So the first seat has to be a parent, so it has to be either mom or dad on the aisle seat. And then, so there's 2 choices there. Who sits on the aisle? It's either mom or dad. And then once we do that, then the other 3 seats are the other parent and then the 2 children. So we have 3 ways to arrange, or we have 3 people and 3 seats. So how many ways are there to arrange the 3 people? That's 3 factorial, so 2 times 6, or 12 ways. Okay. So out of the 24 original ways that we had, we've decreased the number of possibilities by half by eliminating all of the possibilities that had a kid on the end. So there would have been 12 possibilities that had either the son or daughter on the aisle seat. Okay. Okay, next example, still sticking with the theater. Okay, what if the daughter wants to sit by the dad? Okay, so we want to figure out how many ways are there to set up our seating so that the daughter and the dad sit together. So there are 4 seats. Before I was using these dashed lines to count possibilities. Right now I'm using them to indicate the seats, okay? We're figuring out who can sit where. So these 4 seats, and we're forgetting the part about the aisle now because that was part B. Here, we just want to know, okay, the daughter's going to sit by the dad. Okay, so we got to figure that out. So that's complicated. We got to figure out where this daughter and the dad are going to sit, and then the mom and the son. Okay, so notice that this doesn't imply that the mom and the son are sitting together, because the daughter and the dad could take these 2 seats, and mom could be here and the son could be here, right? So the mom and the son are not necessarily together if the dad and the daughter are. So we should figure out where the dad and the daughter will sit. So where dad and daughter. Okay, so there's, let's think. They could take the left 2 seats, they could take the middle 2 seats, or they could take the last 2 seats. Okay, dad and the daughter are going to sit together, so they have to sit in adjacent seats. They're either the first 2, the middle 2, or the last 2 out of the 4 seats that we've allocated to this family. So 1, 2, 3 possibilities. Okay, so then let's just say for concreteness that they take the middle 2 seats. Okay, let's just say. Okay, then we have to think about, okay, if the dad and daughter are going to sit in the middle 2 seats, will the dad be on the left or on the right? Okay, we could have the dad on the left or on the right. So there's 2 possibilities. Let's say who on the left. There's 2 possibilities. Excuse me. So let's say the dad goes here and the daughter goes here. Okay, once we have the dad and the daughter sitting down, which pair of seats are occupied, who's sitting on the left, then we have to seat the mom and the son. And so at this point, there's no restriction on the mom and the son. So there's 2 factorial ways of arranging those 2 people. Okay, so 3 times 2, 2 factorial is just 2. So that will be 3 times 2 is 6 times 2, again, 12 ways. Okay, if the daughter wants to sit by the dad, there are 12 ways for this to occur. Okay, all right, last one. What if we need to separate the kids because they tend to fight, poke at each other and stuff during the movie? Okay, so pause the video, try this, and see what you get with that. Okay, so let's think about it. So we could go through kind of an analysis like we did with the dad and the daughter, but we can actually take advantage of the work that we already did and the complements rule, actually. So in part C, we figured out the number of ways of having the daughter and the dad sit together. We saw that there are 12. So if instead of making the daughter sit by the dad, if we make the daughter sit by the son, just replace the dad with the son for a second, then there would still be 12 ways. Right, we've just swapped the dad, the daughter, the son for the dad. So there's 12 ways to have the son and daughter together. Okay, and we know that there's 24 ways that the whole thing can happen. So using the complements rule, if there's 12 that have the son and the daughter together, there has to be 12 that have them apart. Okay. So the final answer is going to be 12. 12 ways of having the son and daughter together. Another way to kind of re-explain that, we saw in part C that there were 12 ways to have the daughter sit by the dad. If there's 24 ways altogether to seat everyone, and 12 of them have the dad and daughter together, the other 12 would have the dad and daughter apart. So if we replace the dad by the son, then there will be 12 ways to have the son and daughter apart, okay? All right, just for fun, let's see about answering this last part directly. So I'm gonna organize the work in the following way. I'm going to, I've written out 4 possibilities for different places where we could locate the sun. So I'm gonna place the sun first, and then place the daughter, and then we'll work in the mom and dad around that. So the son could be in the leftmost seat, if he's in the leftmost seat, then the daughter, sorry, that was supposed to be the son first. So if the son is in the first spot, then the daughter can't be in the second seat because they're not supposed to be together. So the daughter could be either here or here. So there's two possibilities for where we place her. And then once we do that, then we have two choices for how to place the mom and dad. Okay, so there's 4 possibilities. Okay, so then, let's make those look more like these. Okay, so instead, let's have the son sit in the second seat. If the son is sitting in the second seat, then the daughter has to sit here, right? She can't be next to him. So she's sitting here. So then all that's left to do is figure the 2 ways to place the parents, mom and dad or dad and mom. Okay, so in the second case where the son is in seat 2, there's only 2 possibilities because the daughter has to be in seat 4. Okay, finally, if we have the son in seat 3, then the daughter has to be in seat 1. And again, there's 2 possibilities for where we can place the mom and dad. Okay, and then finally, if we have the son in seat 4, then there are 2 places to put the daughter. This is kind of the mirror of the first situation. If the son is in seat 4, there's 2 possibilities for where we can seat the daughter. So which seat should she be in? Okay, and then once we've decided which of those 2 seats the daughter will occupy, we still have to have 2 places or 2 possibilities for the ways of arranging the mom and dad. So there's 4 possibilities. So adding together the box numbers here, we have a total of 12. So this is the same 12 ways. Okay, all right, so that takes us to the end of this part of section 4.4. In the next video, we're going to continue with section 4.4 by looking at combinations and permutations. In the meantime, let me know if you have any questions and have a great day.